This is Algebra 2 with trig. We are working on the Unit 7 review, or this practice test. Tell whether the sequence is arithmetic, geometric, or neither. Write the next term and the explicit rule. Well, this first one's kind of tough, huh? You're not adding the same term, because 5 minus 2 equals 3 and 10 minus 5 equals 5. You don't have a common difference. And 5 divided by 2 and 10 divided by 5, you don't have a common ratio. So that's not happening. So this falls under neither. And as I look at neither questions, I always put a 1, 2, 3, 4, and 5 above those numbers, and I try to figure out a pattern that creates these terms using that number. And remember, that number is the position number. We typically call that the letter n. So what I notice, I'm not squaring anything or anything crafty like that. It's just the position. I take that back. We are squaring it. This is position squared plus 1. Position squared plus 1. So A of n is going to be the position squared plus 1. So to get the sixth term, I'm going to square it to get 36 and plus 1 to get 37. In this case, I'm multiplying by 3, and I'm multiplying by 3, and I keep this pattern going. So this is clearly geometric. So geometric's a nice easy one, remember. The explicit formula for geometric is a of 1 times the ratio to the n minus 1 power. So my a of 1 is 3, my ratio is 3 to the n minus 1 power. So if I want to know my sixth term, I plug a 6 in here, which is 3 to the, this should be 3 to the 5th power. So 3 to the 5th power times another 3 gives us 729. You can also get that by taking 243 and timesing that by another multiple, another ratio of 3. Either way you think about it. We're going to write a series using summation notation. Summation notation is using the sigma, and we always want that to start out. Our formula is going to be using where n equals 1. Now notice how this is adding, so it's a sum, that's why we're using summation notation, and it's dot dot dot, meaning there's no additional term, there's no end to this series, so we're going to use the infinity symbol. Now again, I'm not adding anything specific to the fraction to get the next fraction, but I am adding something to the numerator and something else, or the same thing perhaps, to the denominator. 1, 2, 3, 4. So my position plus 4 and my position plus 5. Now whenever you have your rule, you should be able to test it. I want the third position, so that means I plug in a 3 for n. 3 plus 4 gives me 7. 3 plus 5 gives me 8. So that's my summation notation. Here's one. Now in this case, we're multiplying by a negative 3. And in this case, we're multiplying by a negative 3. And in this case, we're multiplying by a negative 3. So our common ratio is negative 3. Our R value is negative 3. This implies that this is geometric. So to do the geometric again, I'm going to use the format of a of 1, r to the n minus 1. my first term is negative 3. My ratio is negative 3 to the n minus 1 power. Let's test that. Let's see if we can get the third term. So we plug in a 3 here. 3 minus 1 gives me 2. When I square negative 3, I get 9. Positive 9 times a negative 3 gives me a negative 27. And to get my second term, I plug in a 2. So 2 minus 1 is 1. So I have negative 3 times negative 3 gives me positive 9. Perfect. We're going to write an explicit rule. So the explicit rule, this has an R, so again, this is geometric. So we're going to be using the format we've been talking about. What I don't know is what my first term is. I know that I get the 54th term. I don't know my first term. I know my ratio is 2/3. I get my 54th when my n is 2. So 2 minus 1. So that's 54 equals a of 1 times 2/3, because that's 2 minus 1 is 1. So I'm going to multiply by 3 and divide by 2. So another way I can do that is take my 54 and times it by the reciprocal. We get 81. So a of 1 would have to equal 81. So my rule is going to be a of 1 times 2/3 to the n minus 1. So now I should be able to plug in a 2 and get 54. Two minus 1, I should get 54. So then I should also be able to plug in a 10. And I'll get a much smaller number. So this is 2.11. And then with most calculators, you can hit a button and you can get the fraction version of that. 512 over 243. So either version that you would do, if you wanted to work with your 2/3 and raise it to the 9th power, that would be a little tricky, but you could do that, and then you could times it by 81. In this case, we see that we have a D value. Our D value is 4. So this is arithmetic. So with the arithmetic form, we do a of 1 plus d n minus 1. What I don't know is what my first term is. So I can plug in 16. I'm looking for a of 1. I know my d is 4. My n value is 4. This is 3 times 4 is 12. Subtract that across and I get 4. So my first term is 4. So my rule, let's calculate this out now. A of n equals my first term plus my difference times n minus 1. Distribute this through, and I get 4 plus 4n minus 4. So this is just a of n equals 4n, which makes sense for here. This is 4 times 4, which is 16. The 10th term is when we plug a 10 in, and we get 40. Next, we're going to write an explicit rule for the nth term. Now, we're told that this is an arithmetic pattern, sequence. So, there's a couple different ways. We have done it in class one time where we did the slope. So we did 21 minus 97 and 27 minus 8. So we got, what is that, negative 76 over 19, and that equals negative 4. So we know our D is negative 4, which is our slope. Then we could use our y equals mx plus b, and we could plug in our 21, our D, which is our slope, times our x value, which is 27. This is negative 112, 108. I'm going to add the 108 to the other side. So this gives us 129 is our b value. So a of n equals negative 4n plus 129. That's one way to do it, and we can test it. So we're going to take negative 4, plug in our 27, and add 129 to it, and I got the answer of 21. The other way to do this is to use the format of a of n equals a of 1 plus d n minus 1. So we're going to plug in our 21. We don't know what the first term is. We don't know what the difference is. We get 21 by plugging in 27, so 27 minus 1 is 26. We'll just jump to that. And when we plug in 97, we don't know what a of 1 is. We don't know what the difference is. But when I plug in an 8, 8 minus 1 is 7. Now we're going to treat this as a system of equations. So we're going to multiply through and subtract each of these terms. So we're going to get our 97, negative 97, and subtract the 21, which gives us negative 118. These cross out completely, and we have 7, essentially it's like negative 7d. So our 26 minus our 7 gives us 19. So this is going to be 19d, or d19. So our 118 divided by the 19, well, you know what, this is not 21 minus 97 is negative 76. Okay, and that we know when we divide it by 19, we get negative 4. So that's just another way that you can get your common difference rather than doing slope. Slope is probably smoother. But this y equals mx plus b is kind of funny, but this is something you've learned in the past. Anyway, once you know that, you can plug it into either equation. Doesn't matter which one. So 21 equals a of 1 plus a negative 4 times 26. So this is 21 plus a of 1 minus 104. And when we add that across, we get an a of 1 that equals 120. Alright, why am I getting 125? Alright, that's because this is just our first term. Our first term is 125. So again, we're going to plug it into a of n equals 125 plus d, which is a negative 4, n minus 1, When we distribute it through, we get -4. Two negatives make a positive, and add that to the 125. Gives us 129. So, just another way to get the same question. Saw this on a video in the past that you guys saw during the break, during the testing week. Alright, so here, let's try this one again. Let's take the 240 equals a of 1 plus d times n minus 1, which is 19. And we'll take the 170 equals a of 1 plus d, 15 minus 1 gives me 14. When I subtract these, I get 70. When I subtract these, they cross off. And when I subtract these, I get 5d. And 5 goes into 7 one time with 2 left over, so I get 14. So now I'm going to take either one of those equations. We'll take this one, a of 1 plus our 14, n minus 1. So 140 equals a of 1 plus 14n minus 14. Add that across and get 184. I have n here, but we know what n is. N is 15. So 15 minus 1 is 14. This is 14 times 14, apparently. And we know 14 times 14 is 196. So we're going to subtract that across. We have 170 minus our 196. That gives us a negative 26. So that's our first term. So we're using this format. So our first term is negative 26. Our common difference is 14. N minus 1. So we distribute negative 26 plus 14n minus 14. These two together make negative 40. So I've got 14n minus 40. Now let's test that to see if we get our values. We're going to say 14 times 15, and we're going to minus the 40. We got 70. And we can test the other one if we like. 14 times 20 minus the 40 should give us 240. That's a perfect formula. Here we're going to write an explicit rule for a geometric sequence. Now here, a couple different ways that we can go about trying to solve this. There was a method that we talked about the other day, which was taking a radical of one term. Let's see, because this is a larger number than that, and let's put this guy on top. 1/4 divided by 2. And this is 5 minus 2. So this is going to become 1/8. This is the cube root of 1/8, which is we take the cube root of the top and take the cube root of the bottom, so we get 1/2. That is our r value. And once you have your r value, then we're going to plug it into our geometric format we've been talking about. So let's use the 2 equals a of 1, because that's what we don't know. R is 1/2. We use a 2, so 2 minus 1 is 1. So multiply by 2. So my rule is 4 times 1/2 to the n minus 1. And we can test that. When we plug in a 5, we get 5 minus 1, which is 4. And 2 to the 4th power is 16. So 1/16. The 16 and the 4 can cross off to make 1/4. Perfect. Always check your answers. So here, to find r, we're going to take our 3072 and divide it by our negative 48. And we're going to take our 6 minus 3. So that's going to give us a cube root again. That's helpful because we don't get a plus or minus answer. We just get a whatever it is answer. So this is negative 64, which is going to be negative 4. So that's our r value. So then we're going to take one of the terms, equals a of 1 times our r value, to the 3 minus 1, which is negative 48. A of 1, 16. When we divide, we get negative 3 as a of 1. That's our a of 1 times our r to the n minus 1. And let's test it to see if it's working out. Negative 3 to the negative 4. And when we plug in a 6, 6 minus 1 is 5. We get the answer of 3072. Find the sum of the series. So sum of the series, this is a finite arithmetic series. We know that it's finite because it only has 9 terms. When you plug in an 8, a 9, a 10, 11, 12, 13, 14, 15, 16 is 9 different terms. The pattern here is arithmetic. It's not geometric. It's not neither. It's in the format of y equals mx plus b. So we're going to use our sum formula, which is n, a of 1 plus a of n over 2. So our number of terms, remember that we're going to plug in an 8, then a 9, 10, 11, 12, 13, 14, 15, and a 16. 1, 2, 3, 4, 5, 6, 7, 8, 9 terms. Our first term is when we plug in an 8. So we have negative 11 plus we have 4 times our 8. So that gives us 21. Our a of 1 is negative 11 plus 4 times 8, which is 21. And our last term, our a of n term, our 9th term, is negative 11 plus 4 times 16. So we take our negative 11 and times that by, and we get 53. So that gives us 974 by 2. So 2 goes into 7 3 times with 1 left over, so that's 37. So 9 times 37 gives us 333. So we could call this S of 9 because that was the 9th term. That was adding 9 different terms together. This here is in a geometric format. It's finite. is geometric because we have this ratio and a term raised. This is raised to a power. Now notice this is not infinite because this term up here is not infinity. So we only have 8 terms. When you plug in a 0 plus 1 through 7, that is 8 different terms. So I know that my n equals 8. I get my a of 1 by plugging in 0. So plugging in 0 is going to give me 2 times 3 halves to the negative 1 power. So that means I have to do the reciprocal, and this is going to be 4/3. And of course my common ratio is 3 halves. That's my R value. So when we find the sum, we take a of 1 times 1 minus r to the n, 1 minus r. So we're going to find the first 8 terms. So if you would like, you can put an 8 down there. That's 2. 1 minus, our first term is 4/3, or our ratio. Let's see, our first term, I'm sorry, I put a 2 down there, but it should be 4/3. So something was weird. A lot of times this is your geometric first term, but because this is not a 1, that changed it. So we have 4/3 is our first term. 1 minus our ratio to the power of 8 over 1 minus 3 halves. That gives me, we'll take our calculator. I'm going to put it in parentheses because it's a fraction. It just helps be sure things are calculated correctly. So we have 4/3. Then we're going to have a numerator. So that 4/3 is timesing something. And in our numerator, we have 1 minus our fraction of 2/3. And that fraction of 2/3 is raised to the 8th power. That closes our numerator down. And then we divide that by our denominator, which is 1 minus. We have a fraction of 2/3. That's not raised to a power. We get our answer of 3.84. So S of 8 equals 3.84. We can take this 3.84, and if we wanted to, we could figure out, oh, it's not liking that this time. So that's the best we've got, 3.84. Here we have infinity, infinite, because it doesn't have a maximum term. The R value is between -1 and 1. Two-thirds falls in between that. So we're going to use S to equal A of 1 over 1 minus R. So our first term, when we plug in a 1, we get 0. 2/3 to the 0 power gives us 1, and 6 times 1 is 6. So A of 1 equals 6. Our R value is clearly 2/3. So we're going to be able to say that 6 over 1 minus 2/3, that gives us 6 over 1/3, which is 18. The infinite sum is going to be 18. we look here and trying to figure out what are we multiplying the top by, times 3 times 3 times 3, this is times 2 times 2, so it looks like the R value is 2/3. We're multiplying, or I wrote that backwards, this is 3/2 times 3 times 3 and times 2 times 2. So of course this is geometric. This is infinite because there's no terms after the dot dot dot. So I'm using a of 1, 1 minus r as my sum. I know what my first term is. I know what my ratio is. That's 1.5. So I take a half and I take 1 minus 1.5. So that's going to give us -1. Here, I notice that this is quadratic because it's k to the second power. It's not linear. It's not y equals mx plus b, so it's not arithmetic. It's not geometric because it's not following our pattern. So this is neither. So for a neither, we're going to have to calculate out all the points. We're going to find a of 1, our first term, by plugging a 3 in. So this is 3 squared minus 1. That's 9 minus 1, which is 8. Then we're going to plug in 4. 16 minus 1 is 15. And we'll plug in 5. Plug in 6. Plug in 7. So notice, I call this a of 1 because it would be our first term, just to simplify that. But it does get a little tricky when you're plugging in a 3 and calling it the first term. Usually when you plug in a 3, that's your third term. So you could get away with it in any format, but there are 5 terms that you're working with. We're looking for the total sum. So we take our 8 plus the 15 plus the 24 and the 35 and the 48. So the sum of our 8 terms is 130. And that's by adding up each of our terms. There's no formula we can use. This is infinite because we have an infinity symbol there. This is arithmetic, so because this is a linear equation, like y equals mx plus b, there's no sum. You can only do a sum if it's geometric with an r value between -1 and 1. We're going to write the first 5 terms of our sequence. This is recursive. We know the first term is 6. We know our second term is going to be 2 times 6 minus 3, so 12 minus 3, which is 9. Then we're going to say 2 times 9 minus 3, 18 minus 3. Then we're going to say 2 times 15 minus 3, which is 27. And 2 times 27 is 54 minus 3 is 51. 1, 2, 3, 4, 5. The first 5 terms. That's the completion of the first page, questions 1 through 7. Find the other video for page number 2.